In this video, we're going to continue our look at subtraction by examining subtraction in other bases. So the first problem that I'd like to start on, let me get my pen going, is this one right here. And I've written it in the chip abacus model, and I'm going to sort of follow along with the traditional algorithm. So in base 5, 223, base 5, and subtract from that 144 base 5. And like the chip abacus model in base 10, a subtraction is a takeaway operation. So what we're going to do is we're going to take away 144 in base 5 from what we have in these chips. So to start out, we have to take 4 ones away from the 3 ones, and again, you can't do that. So what we're going to have to do is we're going to have to do a trade. We're going to take one of these 5s, and we're going to exchange it for 5 ones. That's what's important in other bases, is just know that you are, when you're exchanging, you're not exchanging 10s, you're exchanging 1 5 for 5 ones. And that's reflected here. So we are left with 1 5 after we do the exchange. So there, I've marked it on the tableau. We have 3, and this is one thing that I do that other people may not do. And that is, I like to keep a record of, it's just easier for me to keep a record in base 10. So when I add 5 ones to the 3 that were there, I have 8. So it's just a record for me. Now I can take 4 away, because take away, I'm going to take away 4 ones from the ones that are there, and that leaves me with 4, and that's the first step right there. Okay. Now, we need to take 4 5s away from the 1 5 that we have. But again, we can't take 4 5s from 1. So what we've got to do is we have to do an exchange. So we're going to take one of these 25s, and 125 is 5 1s. Or, 5 5s, excuse me, 125 is 5 5s. And that's reflected here. Again, so what we do is we exchange the 125 for 5 5s. So I mark out my 2 25s, and I have 1 left. Now again, we had 1 5. If I add 5 5s to that, I'm going to mark out the 1. That's what I did here. And again, I write it in base 10 language, so I have 6 5s remaining. Now I want to take away 4 5s from the 6, so I would have 2. And then lastly, take away 125 from the 125 that we have. That's 0. So the answer, when you do the subtraction, is 24 base 5. Okay, so you can continue when you do subtraction in other bases, if it helps, and I think it is helpful. I think the chip abacus model is a powerful model for modeling subtraction problems. What's better about it as opposed to a base 5 blocks or base 7 blocks is that you're able to easily essentially make the problem as big as you want. Base 5 blocks, for example, are sort of limited, and you can't go really past 1,000s because you can't visualize past 1,000. The block, in other words, it'd be 625s in base 5. With the chip abacus, you just keep adding columns and keep track of the columns, and know that when you exchange, in base 5 at least, 5 of the bigger column, or 1 of the bigger column, is equal to 5 of the smaller column. So you can continue to use the chip abacus. I'm going to do 3 problems, the final 3, using just a traditional algorithm. All right? This is the easiest, the ideal problem if you can get something like this. Remember, it's just take away. We're in base 8, 4,277 base 8. Take away 1,263 base 8. There's no exchanging needed. We can take 3 1s from 7. That leaves us 4. We can take away 6 8s from 7, and that leaves us with 1. We can take away 264s from the 2 that we have. That leaves us with 0. And then, what is it? I think 512. We take 1 512 away from the 4 that we have. That leaves us with 3. No exchange is needed. So it's just 3014 base 8. Okay, so let's do a few problems where you have to exchange. So the first one is in base 7. So okay, we've got in base 7 our columns, and I think it's helpful to do this. You've got the 1s, you've got the 7s, you've got the 49s. Okay, I'm going up 7 to the 0, 7 to the first, 7 squared. The next one will be 7 cubed, which is 243. All right, so I cannot take 5 1s from 3 1s, so I'm going to exchange. I'm going to borrow from the 7s column. Leaves me with 1 7. And remember, I'm not just adding, I don't write 13 here, I'm borrowing 7. And again, this is what I like to do. I like to cross out the 3 and actually write it in base 10. So this is going to be 3 plus 7 is 10. Now I can take 5 from 10. That leaves me with 5. All right, let's move to the 7s column. I cannot take 5 7s from the one that's there, so I need to borrow from the 49s column. That leaves me with 1 in the 49s. Now remember, I did not borrow 10, I borrowed a 7. There's 7 7s in 49. So I'm going to add 7 7s to the 1 there, which leaves me 8 when I do the exchange. Essentially, you add 7. When you borrow from one column, you add 7. Okay, so then we can take away. So 8 7s, take away 5, leaves me with 3 7s. Now in the 49s column, again, I need to borrow. I cannot take 2 49s from 1, so I need to borrow from the 243 column. Leaves me with 2 there. I borrowed, or I exchanged rather, 7 49s. So 1 243 is 7 49s. So essentially I add 7 to the 1, which leaves me with 8 in the 49s column. 2 from 8 gives me 6. Finally, take away 1 243 from the 2. That leaves me with 1. So when I do this subtraction, I get 1635 base 7. Now let's do a real challenge for borrowing. Lots of zeros. All right. Students in many bases have lots of problems with this. Okay, so we need to do a lot of exchanges here. So the first one is we cannot take on base 5. So let's think, what are the bases in base 5, or the place values? So you have 1s, you've got 5s, you've got 25s. That would 5 squared. The next one would be 5. 25 times 5 is 125. And the fifth place would be 625. So those are the place values in base 5. Now, let's start with the 1s. I cannot take 4 1s from 3, so I need to borrow, but I can't borrow from the 5s column because there's nothing there, and I can't borrow from the 25s or the 125s. I have to borrow from the 625s, and I have to sort of work my way down. So I'm going to borrow 1 625. Okay, so there's 0 there remaining. Now that gives me 5 125s. There are 5 125s in 625. All right, but remember, I'm trying to borrow all the way down to the 1s, so I need to borrow to the next column. So I'll take away 1 from here. So there's 4 125s, and that gives me 5 25s. I need to borrow again, so I'll take one of those 25s, which leaves me with 4. And I borrow that down to the 5s column, so there's 5 there. And finally, I can borrow into my 1s. I take 1 5, which leaves me with a 4. And that would give me, remember, you don't add a 10, you're adding 5. There's 5 1s and 1 5. So I'm going to take that 3, I'm adding 5, that would give me 8. So let's do the subtraction now. Now I've done all these appropriate borrows and exchanges. So 8, so 4 1s taken from 8 leaves me with 4. 4 5s from 4 is 0. 4 25s from 4 is 0. 4 125s from 4 is 0. And we don't have any 625 less. So the answer is 4 base 5.